This is going to be a harder lesson because there's a number of different ways that you can make a transformation, and you're making equations that have certain transformations in them. So for example, if f of x is equal to 2x plus 1, and the directions say find g of x, where f of x is translated 3 units down of the graph. Well, 3 units down of this graph, f of x, means you're going to be subtracting 3 off of this. In other words, your g of x equals f of x minus 3. And so you can write that down by just saying, oh, it's going to be 2x plus 1 minus 3 f of x, 2x plus 1 minus 3 minus 3, which means that your g of x is going to end up equaling 2x minus 2 when you combine like terms. The next problem is where we're going to have 2 units to the left of the graph f of x. Now, 2 units to the left means you're going to be adding 2 to your x on your f of x. So that means that when you go back to this f of x, you're actually substituting this x plus 2 into your x. Wherever there's an x, you're going to substitute that x plus 2 into it. So it's 2 times x plus 2, and then copy down the rest of it, plus 1. And then when you distribute, you end up with 2x plus 4 by using the distributive property, which means your h of x equals 2x plus 5. Be careful about this distribution here. Let's do another problem. Now we have an absolute value f of x, and the question is to reflect it over the x-axis. Reflecting it over the x-axis means all of your y's become the opposite. So when you have this situation, you're really multiplying negative times your f of x, which means you're multiplying negative by the whole thing, not just the absolute value. So that means that your g of x is equal to a negative absolute value of x plus 3, and then it's going to be minus 1 because you're distributing that negative to this, and you're distributing it to the 1. You can't distribute inside of the absolute value. You leave the absolute value the way it is. Now, when you have a y-axis reflection, that means when you're reflecting over the y-axis, it looks like this, means x's become the opposite. You're dealing with opposite x's, which means that your f becomes f of negative x. In other words, substitute negative x in for x, and that will be the reflection over the y-axis. So that means that it's going to be absolute value of x plus 3 plus 1. That's it. It's a substitution in for x, nothing more. Now, that's not too bad, but you're going to see that they do get a little bit more complicated, such as this one. Let f of x equal absolute value of x minus 3 minus 5. Write a function of a horizontal shrink of the graph of f by a factor of 1/3. Couple things. Horizontal shrink means that it's going to be making your x's such that the graph is going to get wider at the horizontal axis. It's going to be shrinking horizontally. It's not going to hug the x-axis. It's going to make it wider. And in order to do so, the factor actually becomes 3, not 1/3. In other words, you're going to want to write in 1 over 1/3, which is 3, into this equation. So that means that when you're dealing with the horizontal, you're looking at just affecting that x there. So it's going to be 3x minus 3 in absolute values minus 5. That will give you a horizontal shrink because it has a reciprocal relationship with your A, which is 1/3. Looking at the B part, it says a vertical stretch by a factor of 2. Vertical is the same A. So if this is A, 2 is A, then you're going to be multiplying by 2. You're not going to do the reciprocal. So that means that h of x is going to equal, let's see, it's really 2 times your f of x. And when you do 2 times f of x, you end up with 2 times everything. X minus 3, absolute values, minus 5. And that's where you have to remember to distribute. 2 times x minus 3 in absolute values, minus 10. That's your h of x. Now, you can see there are very subtle differences here. Just the word horizontal or vertical changes everything. If it's horizontal, it has to be affecting just the x. If it's vertical, it affects the whole f of x. Horizontal, you have to use the reciprocal of the factor that it's talking about. So if it's talking about 1/3, you have to multiply it by 3. We're doing one more. This horizontal stretch by a factor of 2 again. That really means that your A is equal to 2. So it's a horizontal stretch, so you have to use 1/2 when you multiply it into this equation. So that means that, let's just call it g of x is equal to f of 1/2 x. You're multiplying x by 1/2, which means really it's going to be 1/2 times 4. Scratch that. It's just going to be 4 times 1/2 x plus 2. That's your substitution in for the factor of 2. And therefore, you end up getting g of x is equal to 2x plus 2. Notice there's no distributive on the 4 because it's only the substitution of 1/2 x in for x. Vertical shrink, remember, if it's vertical, you use the same number, so it'd be 1/3 times the whole thing. So it's very subtle, but be very careful on these problems. It's easy to get them mixed up.